All of you have done? Anybody needs help, you raise your hand. I will come to you. Log wala nahi aa rahe? Acha, you don't have this thing, logarithm of that one. Huh? That one you will leave. Other ones you can. You know the rule, the logarithmic expression after the decimals only will be counted as the significant figures. Where is that log? Last one. Huh? So leave it. Other ones you do. Anybody needs help, you can raise your hand. I will come to you personally. Multitasking कर रहे क्या? You need any help? Significant figures, you can just count the non-zero digits, etc. There is a zero, you will have a time to think. Leading zeros are not significant. Trailing zeros will count only when there is a decimal point. Captive zeros are always significant. Rounding of, yes, 1g, 1g, infinite. Yes. 1d you may not be able to exactly tell now, so we will write it is not clear. 1d 5600. No? That in this expression we cannot tell. It is ambiguous. You have to tell that in this stage we are not able to tell. Then this will be the answer for the current. And then if it is an interactive process, then the other person will give you the scientific notation expression. That time you can clear cut tell which part is the number of significant figures. 1c, leading zeros are not significant, trailing zeros are significant. 1, 2, 3, 4, 5. Yes. Got it? No, after decimal also, if they are on the left hand side, they are only place indicators. They are not significant figures. Yes. Only they, even after the decimal, they will be counted only if they come after a non-zero digit. Thing is that by just putting simply zeros on the left hand side, you are not adding to any information. Precision you are not improving. If you are putting zeros to the left side of the expression, you are not improving the precision. Yes. 1g. 1g. G is 50 books. It will have infinite number of significant figures. It is a discrete quantity. The numbers 50 books. You have any doubt? Tell. 50 books. 50 books, if I count or somebody else count or you count, it will be the same only. There won't be any ambiguity. Whenever we have continuous variable to be measured, there may be chances that by doing repeated measurements, you will end up in alternate values. Here in the case of 50 books, unless you miss out one or two books or you count one book twice, then only you will have different number. So that time it will have finite number, predictable number. So it is predictable. It will have infinite number of significant figures. Those quantities which are predictable. Not predictable, actually in words it is discrete quantities. Discrete quantities, that is the word. Significant figures are clear to all of us, na? Yes. D is 5600. Yes. The unit is first thing is that unit is not given. When unit is given, then you come to know whether it is a quantity which is counted, which is just obtained by counting. This may be a continuous variable or a discrete variable. It is not defined in this expression. If at all the unit is given, even then the unit will guide you through. If it is some absorbance value, some concentration value, definitely it will be continuous value. It will not have infinite number. Continuous variables, it will depend on the instrument's precision which you are going to do. Huh. Even then, like in some textbooks, they say that now you can count it. Earlier, 2 years back, we were giving that expression, ki now you count it as infinite number. But recently, this field is evolving. So now the thing is that unless you make it in the scientific notation, clarity is not there. So leave it in that case in the ambiguous state. Okay. So 2 years back, there was some different discussion. If at all anybody goes to the YouTube of HBNI website, there are some slight improvements so in some of the discussions. For example, yesterday's rules for keeping two significant figures and rounding up to the last place value. Last year, there was a different opinion because there was an update after that lecture. So a few of the points, there are improvements in the discussion. So keep attention in the class. You can go through the YouTube for backup, but there are along with that you go through the slides also. There are a few points where there is modification. Which one? Yes. C. 1C. 5. Yes. Which one? 4E. This 10 to the power 5, it is only giving the place value of the digits, the significant digits. So you can represent in general way 16.23 into 10 to the power 4 also. 162.3 into 10 to the power 3, like that. Different ways. Yesterday also I told it is our convention to keep 1 to 10 digits on the base and keep 10 to the power value on the whatever value on the other side. There may be some other set of scientists or some social scientists. They may be expressing it in terms of 2 digits on the base and another. So you will have different ways of expression. That is why whoever represents in the base, whatever be in the base, that will be counted as the significant figures. Place value does not have any hold on the precision. Okay. So right now, whatever convention which one? Two, second one. If do anybody has any doubt regarding the first question, then we will go ahead with the second. Is there any doubt for the first one? No. Okay. This is a local convention. But if you are doing a scientific communication, right now, prevailing consensus is that put the base value, which is from 1 to 10. Okay. So 15 point wala, it will come to 1.5 like that. This is a convention. This is not a rule. Everybody into 10 to the power whatever factor. Okay. That is a consensus right now. Understood? 5.623 into 10 to the power 1. Which one it is? B. See, 5.742. 5.742 into 10 to the power so and so, whatever. Any other doubt in the rounding off? If you have any doubt, please clarify today. After today's discussion, we will not do this one. Okay. Which one? This is only simply addition. Here, absolute uncertainties you can do. Whenever you do multiplication, uncertainty will be on the last digit, least significant digit. So here the rule says that absolute uncertainty is conserved. Here the relative uncertainty, that is why we have taken relative. Here it is only addition, subtraction. Addition, no subtraction even. So absolute uncertainty only will be getting propagated. Absolute this thing, standard deviation, uncertainty where if you are not comfortable. So this point here the variation will be 0.1. Here the variation will be 0.001. Here it will be 0.001. Here it will be 0.02. Whichever has got the lowest variation, this not lowest, this highest variation, highest standard deviation, that will hold. उसका कितना है 0.1 में highest, तो इसमें 0.1 में variation होगा. When you have to see which operation you are doing, addition or subtraction, simplest of the mathematical operation, there you have to just see, count the significant figures, the one having least number of significant figures, least number, those many number of significant figures will be there in the answer. That is the rule. You have to first see what are the operations you are doing. If you have a combination, for each and every step you have to apply the rules separately. That is what I showed you in the beginning. Huh. There is a non-zero digit after this 5. 5 is being dropped. There is a no. But I have told you the rule says that if at all there is a non-zero digit, 2 is a non-zero digit. You agree with that? So there is a non-zero digit after this dropping digit. If at all anybody has confusion in the previous this thing, significant figures, you clarify today. There is a non-zero digit here. That is right. You have to tell whether it is a counting number or not. If it is a discrete variable, 1, 2, 3, 4, like that, then that means whether 2 or 3 people do the job, they will get the same answer. If it is a continuous variable, 0.1 लगा के अब 600 आए, तो उसमें chances are there कि 600 के बदले 600.1 भी हो सकता है. Here we are not sure what is the unit of that quantity. Unit is not mentioned, so you cannot tell. So we tell that it is confucius, ambiguous, cannot tell. If at all the unit were given, we would have thought of, if it is 600 books, 600 rupees, 600 people, then you count it as infinite. If the unit is not given, we are not able to judge. Is it clear? In this way you represent, we are not sure unless you write the unit. In this way you represent whatever is in the base, those are significant. Okay. We are not sure about the number of significant figures. So there in the bracket I have written number of significant figures are not matching. There was a comment on that bracket. So here, because you have to get rid of this type of representation, you have to go for this one only. In any scientific communication, you try to represent in scientific notation. So this decimal representation is helpless in that case. It fails in that case. पैसे और एक होगा और एक था. So this decimal representation does not always prevail to help you out. So in the case of statistics, it is always better that you go for scientific notation. Decimal representation is not able to give you the idea. So that is what I wanted to convey also. For everybody, do not round off in between. Intermediate rounding off you should not do. Rounding off should be done only once in an entire set of calculation. You should not do rounding off in between, only in the last. And when we have multi-step operations, the rule will be you have to keep 2 significant figures for the standard deviation, then go for the place value of the least significant figure in the standard deviation for the average value. Okay, do not round off in between. Okay, yes. If anybody wants to see the answer, I'll just click and come to you. 2D. Okay. 130. It is 50. And what is there? 1. 501. Which question it is? 2D. 4.129501. So after the 5 is the digit being dropped. Na? Everybody listen. For 2D, we have to round off to 4 significant figures. The dropped digit is 5. Just after 5, there is a 0. But followed by 1. If at all there is any non-zero digit after that 5, you have to step up, irrespective of odd or even digit being retained. So it will go up 4.130. Okay, is it clear to all? 0 4.130. It is correct. Is it clear to all? Yes. In between. Yes. This is multi-step calculation. Don't round off in intermediate step. You have to keep all the digits till the end of the operation. Then only you have to do the counting of significant figures. This is one step of operation. This is another step of operation. Okay. You should not round off because it is not ending here. We should not round off in between. Okay. Multi-step means an operation involving more than one mathematical operation. Maybe plus, addition or subtraction. Maybe a combination of both. Maybe more than one addition. Even that time, you should not round off in between. Rounding off is actually essentially for the convenience of representation. It is only to show that if you have a large set of data, if you put so many digits after the decimal points, your table will look clumsy. In order to avoid that, in order to make it presentable, we are sticking to 2 significant figures as of today. Maybe tomorrow we may change the convention. Maybe tomorrow scientists feel that we should go for 3 or 4 significant figures. Accordingly, it will change. As of today, we keep 2 significant figures. That is why I told you it is only a convention to keep 2 significant figures. So by this time, all of you might have given a try except 3C. Everybody can have a quick check through. If everybody has checked, I will go to the next one. Not it. Should I read through? 186. I'll read through the numbers only. 6, 3, 5, ambiguous, 4, 5, and infinite. Shall I go to the other one? 10.56, 5.74, 2 into 10 to the power minus 3, 9.627 into 10 to the power 5, 4.130 into 10 to the power 6, 56.23, 1.590 into 10 to the power minus 4, 2.890 into 10 to the power 6. Okay? When you do this combination of mathematical operations, try to follow the steps initially at least. For calculating the standard deviation, final result, final value, you can take help of calculator or Excel sheet. But for doing the standard deviation calculation, once at least you give a try yourself manually by writing down on your paper. Yes, previous. You want to check once again? If you have done, then I will go ahead. Done? Here, first one is addition of two quantities. Absolute standard deviation or absolute uncertainties are additive. Here, simply you can count the number of significant figures and put the standard deviation. But here, we do not do the rounding off. Keep it as such. Because there are other operations followed by this. The same quantity is being utilized further. Second step will be the division of two quantities. Division of the adduct by that number 0.0042.6. Sorry. Even here you don't do the rounding off. Third will be the subtraction. All of you will be getting the slides. Try to do at least one operation of multiplication or one division so that you get familiarized with that step. Doubt? Ten point 10.378 plus 0.0025. Yes. Yes. Which one? You should not round off. Yeah, actually, I have copied the Excel sheet. Excel might have rounded off. You should. That is why I told you manually you do. This is actually Excel sheet copy only. You should not round off. Last year, actually, I didn't give the answer to the class. Last year, I had given it as a do-it-yourself problem. But they also felt that they should see the Excel sheet, continuous Excel sheet. Then I copied it and kept for them. If you do in Excel, it will do the rounding of generally for four significant figures. Please do not do that. Please do not do. In the last only. You assure that it is my last step of calculation, then only you go for rounding off. Okay? You should not do. You should not do. Addition, there won't be an issue, but multiplication, once you give a try, at least. If you have a doubt, you can ask me. Doubt happen? Yes. The title you want me to read through, or you are not able to see? Second column in all. This is standard deviation. I have written U. Nowadays, people are encouraged to use the word uncertainty rather than standard deviation. Okay. Error propagation rule, we have used yes, because that rule was originally evolved as error propagation. That rule we extend to uncertainty evaluation. Now, standard deviation, we are all encouraged to replace it with uncertainty. Okay, that is it. So now we will try ourselves to practice that. Uske liye I have kept it as U. It is same as S. Square, we have seen that when you do multiplication or division, relative variances are additive. Variance is nothing but square of this uncertainty or standard deviation. That is why we have squared it. Here, this shows the entire calculation. If you have understood the error propagation rule, some of you may be very bright. You can do on your mind and do the calculation. No issue. This is for those who want each and every step to be written. If you are able to do a calculation in mind, no issue. Ah. Blue one, in the blue one, in the yellow one. Ah. Square root, square root, square root. Na? Yes, yes, yes. Some of the previous. Which one? 0.001004988. We should not round off. We should never do the rounding off. That is why I asked you to do manually, not to take help of Excel or any calculation. That is not actually rounding off. It has been given many digits. Yes, what is your doubt? Very long number, but these calculations are internal. We are not showing in our paper. In the paper, it will be the finally refined data. Otherwise, we will give this. If at all the referee wants to get a check of your calculation, we will keep it as a supplementary information wherein without rounding off, you have to show the entire data. Normally, these Excel sheets do not form part of your publication. Yes. When you use a calculator, please do not do the rounding off at all. Take down whatever is written on that. And in the final one, because each step of rounding, there is no rounding down, either retention or rounding up. So every time you are doing on the positive, there is a positive systematic error. So each and every step, if you are doing systematic error, those will get added up. Rounding off is not essential, an essential part of scientific communication. It is only for ease of representation. So only once you have to do. When you take help of calculator, try to note down as many digits as possible. Nowadays, I think 16 digits are visible. More than that is also visible. I don't know. Around 16 is the general convention. Please do not round off. There may be rounding off seen in the slide. That is due to the exact copy paste of Excel sheet. You do yourself and cross check the final answer. Okay, final answer. I would like to see your answer essentially in terms of the number of significant figures. Even if you do a mistake in multiplication or division, it is not a much issue because I know that people all will use computer for the calculation. But whether you have understood the concept of significant figures or not, that is, yes, calculators are allowed in the exam. And later on, we will study some statistical tables. Mostly, like earlier, we used to ask them to bring the statistical table. Now, it will be part of your question paper. Statistical tables we will learn later. Abhimanyu, done?
आने के बाद जब रिजल्ट लिख रही हो
हाँ.
तो वो कब कितना सिग्निफिकेंट नंबर पर लेना है?
Two significant figures in the standard deviation. पहले आपको standard deviation को check करना है. हाँ, उसका जो फिर second जो least significant figure है, उसका place value तक आपको result को rounding off. This will be first decimal, second decimal, third, fourth, fifth decimal तक. 5, 7 आप report करोगे, then you will have the number of significant figures you have to count. Now you have to keep two significant figures in the result. That is the convention right now. तो ये zeros तो significant नहीं है. Then you have 5 and 7, two significant figures. तो 7 का place value हमें देखना है. इसका place value है 5th decimal. तो इतने तक you are able to report. This one. You see, for the power, it will be like this. For the power ones. For the power, it will be u is equal to a x to the power b. Then the relative uncertainty will be b into sigma x by x. Understood? Okay, this is relative uncertainty in u. Similarly, here instead of u, you will be substituting a, area. Sigma a by a. It will be 2. 2 comes from that substitution of b. 2 into s r by r. Okay. If anybody wants to go out and come in 5 minutes, you can. This is 1 hour. Now you can take 5 minutes break if anybody wants to go out. Or agar if anybody wants to continue, you can give a try. L square का कैसे करेंगे? L square, L into L multiplication. L square का आप पहले कर लीजिए. L square का uncertainty how will you calculate? Relative variances are additive. आपके पास L का वैल्यू है, उसका अनसर्टेनिटी है, उसका डिड यू अंडरस्टैंड व्हाट इज रिलेटिव अनसर्टेनिटी? तो रिलेटिव अनसर्टेनिटी है, उसका L स्क्वायर करेंगे. आप पहले इतना ही देखिए, L स्क्वायर ओनली. You have to calculate what is the uncertainty for L square. How will you do? Only L square. How will you do? Where from 0.1 has come? I'll come to. This is uncertainty itself. Plus or minus, that means that is uncertainty. If in the previous one, why did we take 1? The uncertainty was not given. If uncertainty is given, you have the value directly. उसका रिलेटिव करना है ना, रिलेटिव अनसर्टेनिटीज, फिर उसको प्रोपगेट करना है. 5 divided by 125, that will be the relative uncertainty in L. Did you understand? Then relative variances are additive. Relative uncertainty को square कीजिए, that is relative variance. When you do multiplication of L with another L, same L, so the uncertainty will be the same. Propagation will be 5 by 125, 5.0 by 125.0 rather, square, plus another 5.0 by 120 because both are L. Take the sum. 2 बार, फिर sum करके square root. That will be relative. Which one? Here, R. This I will cross check one, whether it is 6 or 0.65. That I will cross check. I will cross check and tell you. Okay. Did you understand? Relative uncertainty means uncertainty by value. Here uncertainty is given. When the plus or minus is given, that is uncertainty only. Yes. Del R by R. Which way? Which one? Radius.
Del L by L plus 1 by 8 into del H by L.
This you have to square. This is a division operation. So you have to take the relative variances as are additive. Del R by R, the whole square will be equal to. So this is only relative uncertainty. Relative uncertainty. You have to square करेंगे, then it will become relative variance. The rule is relative variances are additive. इधर आप square करोगे, इधर आप square करोगे, इधर everywhere square terms. इसमें एक ही ऑपरेशन था ना, उसको एक ही जो करना था. इसमें you have got multiple this thing. one multiplication, another division. इसमें एक ही था.
इसका whole square वैसा.
Whole square, इसका भी whole square, इसका भी whole square. And when you have this thing addition, in addition, absolute variances are additive. You have to do addition operations separately. When you have identical operations like multiplication or division, they are of identical kind in mathematics. There you can do relative variances rule. Maybe you might not have got the slides. That is why you are getting confused. Relative variances are additive in the case of this mathematical operation, division. This is the point everybody mistakes. Once you attend the class, you should understand relative variances are additive. Standard deviation, because one of the property may have a positive standard deviation, another may have a negative standard deviation. Then we cannot make them an additive property. Additive properties will be like that. They will have identical sign. No, then you take square, it will never go to the negative side. From less than 0, it will never go. So we take, for convenience of calculation, take the square, add them, then take the square root, so that always there will be a positive magnitude, because errors never get cancelled. Understood? Yes. First square, then you sum it, then take square root, not division. Take square root, because we have squared just for the convenience of addition, because never these errors get cancelled out. When you take the square terms never get cancelled. They will only go into the higher side. Okay. Yes.
Memorize this formula for example.
Formula you need not. That is why I am telling you, even if there is slight variation in the actual value, I am not much bothered. I will be focusing on the standard deviation part rather. Whether you have done the rounding off properly or not. Instead of 100, instead of 10, if you write plus or minus, I understand that calculator has misled you. Or maybe exam में tension के वजह से you lost that decimal का. Pardon? Difference. You need not have to know differentiation. You know multiplication.
Yeah, I can
You know division. You know division.
derive the area like 5 and 12. Then the
That
value
will do.
I will just write.
I am not bothered. I am not bothered whether you know differentiation or integration. So that is why I have made it as simple as possible. The example also. The answer is given to you. You have to round off the figure. Understand the rounding off. I will be happy if you have understood the rounding off. Whatever mistakes are there in the calculation, I am not bothered much about that. Because nowadays nobody is going to do manual multiplication or division or even differentiation or addition, subtraction, whatever. And finally, you get the entire data set. How will you make it presentable? हम खिचड़ी बनाए, अच्छा बनाए, तो then we will give it to the guest ना. अगर वो थोड़ा नीचे चिपक गया तो हम क्या करेंगे, वो पार्ट निकाल के अच्छा पार्ट only we will present it. It is like that only. We have made the thing, we have put our entire effort, and whatever has come as the good presentable form will be given to them. Okay, make it as presentable as possible. Yes. किसमें किसको 2L 2 delta L by L. हाँ. Yes. 8 is a constant, na? So 8 has got no uncertainty. So when you multiply with the constant, uncertainty is not affected. But when you take relative uncertainty, this constant gets cancelled out. Value by that number. The relative, then 8 gets cancelled out. Okay. It is not required. 8 का uncertainty जो है वो उसी में cancel out होगा. ये हमारे पहले slide में it is there. Pardon? Square ना, ये सब आप square लिखा है, टिक तो नहीं है. Okay. हाँ. H by H. ये देखिए, ये H किधर से आया? हाँ. You see, this is a set of identical operation, multiplication or division. This is another different kind of operation, addition. Keep it as a separate one. Addition के लिए rule अलग है. Absolute variances are additive. It is not relative. This part won't be there. Negative. Error can be negative. Variance cannot be negative. Error can be negative. So we cannot add, we are adding the squares of the variations. Yes, this part you cannot keep as such directly. You do, that is why I told you do the stepwise. This part is addition ना, addition के लिए rule अलग है. Absolute variances are additive. उसमें सिर्फ simply आपको h का जो variance है उसका ये square करके sum ही करना, relative नहीं करना है. Keep it separate. Keep it as a separate step. Any other doubt? Separate करके you have to do.
तो फाइनल ये वाला यूज करना है.
ये फाइनल हो गया आपका.
मतलब ये दोनों को सेपरेट करके मैंने डिफरेंशिएट किया. मतलब dr by dl और dr by dx.
हाँ.
ठीक आया.
हाँ.
तो उन दोनों का पहले यहाँ पे पुट करते हैं.
It will be that is you are going by the differentiation route. Normally, simplest way for everybody to understand what I do is L into L multiplication. L by means whatever numerator by denominator H. The multiplication ka rule. Relative variances are additive. That rule. Here again, relative variances are additive. Once this is done, this part is one of the RHS is done. Here it is addition rule. Addition ke liye absolute variances are additive. Then here the thing will be, for this part you are calculating relative variance. For this part it will be absolute variance addition. So that is why you cannot club them together. Do it once, come to the conclusion for addition, multiplication, then apply for the addition separately. Which one? Separately. That way you have to do. You cannot club it together because here your answer is in relative term. Here the answer will be in the absolute term. Then your LHS you have to change. Left hand side you have to change. So do it in stepwise only, always. Although in order to understand we do the derivative part, but when applying you have to see what are the operations involved. Separately you have to apply. That is where you may lack, like you have understood the concept, but while applying, what will happen? Here instead of absolute you are taking relative, na? Then actual value karenge, to then again you will multiply with that value. Then you get a magnified uncertainty. Yes. Which one? I do not know how to show it, like how to change it. If you can help me, if anybody can help. If anyone of you can help me to move it aside, I will do. Please. Move it aside. पेन भी लाना पड़ेगा. उधर से पेन भी लाइए. पेन भी चाहिए मुझे. ये है ना, ये लेसर पॉइंटर. अच्छा उधर. इसका इरेजर ये ना. Which question you want me to do? Which one you want me to do? This one. L square. L square by 8h. So the similar way which we did in the previous question, we will make it into different part. This will be part 1. Denominator में only multiplication with a constant is there. Constant does not have any error. So you leave it as such. This will be step 2, division. Multiplication. This is a DIY. Do it yourself. Now I am doing it. Huh? Now you got it? How to? Error propagation rule. You have done it. So for L, I will not derive the entire one. 5.0 divided by, please see this is the value or not. This will be, how to erase it? How to erase it? You want the final answer or your derivation? Which root over? This formula. UL by L will be, UL square by L square, sorry. UL square by L square. The formula for how to do that? Everything is gone. Some other term I will use. Say A is equal to X into Y. If I write the uncertainty as U and the variable as subscript, U of A will be U of A by A, the square. Relative variance will be U of X by A, the square, plus U of Y by Y, the square. Okay. Here in my numerator it was L square, that is nothing but L into L. So now U of L square by L square is equal to U of L by L, the whole square, plus another U of L by L, the whole square. Okay. If you have to take U of L by A, it will be square root of U of L square. So this is relative uncertainty in L square. Relative uncertainty in L square. If you have to calculate the uncertainty in L square, it will be L into square root this part. 2 into UL by L, sorry, square. Okay? Is it okay? This was the equation we discussed yesterday. Now we have calculated L square. We applied the relative variance of L square will be sum of the squares of the input two relative variances. We have taken square root over here. Then we got the relative uncertainty in L square. The absolute uncertainty will be this L square, sorry. Here it will be L square. This will be the answer. Okay. Now the second step is, this is my numerator divided by 8H. 8 is a constant. H has got some uncertainty, 0.51 plus or minus 0. Similar way, when you divide by H, the error propagation rule will be same. Okay, you can do the division 120 square karke, 125 square divided by 8 times that of H, 8 into 0.5. Plus H by 2 also you can do. Anybody else has done? Given a try. 3829, then 466. Okay. Now, as per the rule, we go for two significant figures in the standard deviation. And yes, yes. First question. Which one? There the formula contains R square. R square. by equation. Let me check one more. That I'll check and then the other. It is right only. I have taken from some textbook. I will check. The second part also, all of you can give a try. Similar way. Yes. 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 Which one? Ah. Hmm. You have to propagate it. It is not adding, it is propagation. Relative answer, relative variances. Relative variances are getting added. Relative variances will get added up. Okay. While adding, you are asking, then absolute. Then absolute, yes. Then I thought you are talking about the division part. If you are taking addition, only absolute. Ah, okay. Which two different parts of the question are you asking? Ah. Hmm. Okay. L, you have calculated for L. Yes. H, there is no this thing, further multiplication or anything. Since it was L square, we had to do that operation. H is singular variable as such. It will be a division operation. There you have to apply that error propagation. L square is the numerator. That is why I have written numerator. Numerator by denominator. That is a division operation. There again, another relative variances are additive. That equation. Once you have done the first part of it, you go for the addition of L by H by 2. H by 2, there is no error. Whatever error is there, you can take and divide it by 2. In addition, it will be absolute uncertainty. You have an error of 0.22, na? 0.22. It will be 0.11 on the right hand side. Square, take it square, take the square, then sum it with the resultant of the left part of the right this thing. Division question ke baad, then you square it, sum it, take the square root. That will be the uncertainty for your calculated radius. Okay, understood? Which one? For multiplication and division, u of the product or u of the quotient by that value, the square will be equal to sum of the relative variances of each of the constituent. But for addition, you will have absolute variance. U of x plus u of x square plus u of y square, sum it, take the square root. That will be your absolute answer. In addition or subtraction operation, we never go for relative values. Okay. Whatever values are obtained, they get propagated. We do not use the term added or subtracted. They get propagated. Okay. Understood? Any doubt? Any other doubt? You have to do it separately. Addition or subtraction you can club together. Multiplication and division you can club together. But do not club addition with multiplication or addition. Yes, yes. Everywhere, everywhere. Understood? If at all there is any calculation mistake in the calculated area, leave it aside. Try to focus on what is a standard deviation. Done. Not done? you can do whatever we have done in the previous example, similar way, so that you get familiarized with this multiplication division problem. Area of a triangle is equal to half the product of the base and height. If you are asked to do any calculation, the underlying equation will be given. Okay. And if at all any logarithmic table or statistical table is required, that also will be provided to you. When you do your research, you can get the relevant data from internet. If you are, yes, I shall share. And this, whatever is required, necessary corrections, after that I will do. Okay. If at all anybody needs, like if you have not contacted me, please give me an email so that I can respond to that email. Physics wala, you are from physics. Today evening I will be sending, because I may get confused. Ki physics and chemistry people, I have sent the three lecture slides. So today evening I will resend to all of you. Okay, including you. If anybody wants to try, please give me an email before 5 o'clock. By 5 o'clock, I will be reaching back to office and I will give you a mail. Area is calculated from the base and height measurements. Here, simply the product of base length and the height length. You have to do the propagation. Yes. Now you have to do one more job. Comment on the individual contributions towards the final uncertainty. Among these two, base and height, which one has got a larger contribution to the uncertainty? We calculate via the relative uncertainty, no? So which one has got a larger relative uncertainty? Maybe you can tell in terms of the fraction or the percentage. All of you can try. Yes. Which one? Because UL by L the whole square plus another UL by L the whole square. Because L into L. It was L into L. No? UL by L the whole square plus UL by L the whole square. The same thing. It will come out to be the same thing only.
If I use that approach, we are having two as a vector.
Okay.
In this one, I am having two as a vector.
It will be 2 only always. Maybe while writing down, I might have done a mistake. It should be 2 only. 2 only. It should be 2 only. Whatever is given in the slide is correct. Whatever is given in the slide is correct. Yes. Then first one will be right. Maybe here while writing down, I'm not comfortable writing on that whiteboard. Maybe something is missing. Has anybody calculated this one? Area? Have you done? Has anybody done the calculation? 25 plus or minus. Then you can comment on which the comment also you have written. Height has got greater uncertainty. Here you have to comment based on the relative uncertainty. Relative uncertainty will be square root of that. Yes. Height and this thing, height and base. Height is how much? 10. 10 plus or minus 0.3. If you can see that the absolute uncertainties are 0.1 and 0.3. But the relative uncertainty will be 0.1 by 5 and 0.3 by 10. Yes. Yeah, you have done the attendance sheet. When you do this multiplication and division, the relative term 2 gets cancelled out. Only in case of this mathematical operation. Addition and subtraction remains. Yes. Relative uncertainty. Yes, you have to multiply with. When you are asked relative, take the ratio between the uncertainty and the value. When you are asked to do the absolute uncertainty, after the multiplication or division, multiply with that denominator, area value. Then you have already done. Then you make a comment on that, which one has got the larger contribution towards the uncertainty out of base and height. Out of base and height, which has got larger contribution towards the uncertainty, relative uncertainty. You can say that if the uncertainty values are same, here in the case of the uncertainties are slightly different, relative value will be, when you divide by the smaller value, the relative value will be larger. Okay. Now that many of you have done, I will show you the answer. So in this table, it is summarized. What is the uncertainty in the base? What is the uncertainty in the height? What is the absolute uncertainty in the area? So from the question, from the measurement itself, we can say that the absolute uncertainty in height is bigger. It is 0.3. And absolute uncertainty in the base is 0.1. 0.3 is 3 times higher than that of 0.1. Whereas when you come to the rightmost side, relative uncertainty, you see the relative uncertainty in the height is only 1.5 times higher than that of the base. So if the value of the measurand is larger, for identical, almost identical uncertainty, relative uncertainty can be controlled. That means when you are going to measure smaller and smaller values, go for much more precise tool. That is what essentially it says. In the next problem also, you will see similar case. In the next one, it will be much more visible to you. Absolute uncertainty in the height is 3 times that of the base. However, the relative uncertainty is only 1.5 times. And we are doing a multiplication operation. So it will be a square of that uncertainty, relative uncertainty. That is why 1.5 square times will be the contribution from the relative uncertainty of the base. When we are measuring smaller and smaller quantities, you have to use better precise tool. Otherwise, you will be landing up in larger values of uncertainty. Okay. All our efforts are to minimize the uncertainty. Accordingly, you have to pick up the tool. If you are asked to measure a length of 100 centimeter, you can use a scale. If you are asked to measure a length of 0.1 centimeter, you can use a vernier, which has got a better uncertainty. Now all of you have done this. Do this one. These are simple calculations. You have to only do the multiplication between length and this thing, width. Area of a rectangle is nothing but the product of length and width. Here you see the length and width both have got same uncertainty. You understood uncertainty is the value given after the plus or minus symbol. This is simply multiplication. Shall we go ahead? This is even much simpler than the previous one. So here it says that when we are measuring smaller quantities like in between 22.1 and 7.3, 7.3 is a smaller quantity. While measuring the smaller quantity, you be more careful so that in terms of your care as well as the better precise instrument, so that your uncertainty can be under control. So rather than spending much of your efforts to do better measurement for the length value 22.1, if you want to improve the precision, you focus on the smaller values. When you are measuring smaller, wherever there is difficulty, you will try to focus yourself more. You will try to do the experiment rather more carefully, so that the data is more elegant, more presentable. For example, if you are good at maths, you are weak at social science, for exam preparation, what you will do? You will dedicate more time for the preparation of social science. Maths, you can just quickly go through and go ahead. So that way, wherever the vulnerable part of the measurement is there, try to focus upon that so that you get the refined data with the smaller spend of time. That is the idea. Shall we go ahead? Using the error propagation formula, you can write what will be the uncertainty in X and Y. We have discussed all the cases. Addition, second one is a subtraction, third one is a power function, fourth one is a product and power. Yeah, product you can say simply. Power is multiple product. And addition of two powers. And the second question is similar to whatever we have done in the class. We just did the calculation of area of a rectangle. And from that we concluded we have to be more precise while measuring the width of the rectangle, which one is a smaller. Here again you can see that the resistance is a function of length of the wire and the area, cross-sectional area. So which part of the measurement you should focus upon to improve the data? Length is a larger quantity, cross-sectional area, the radius will be smaller. Obviously, you have to focus upon the radii, and another thing is that you are taking a square of the radius function. So that error gets propagated during the radius function utilization. So that way you can focus upon wherever is absolutely necessary to improve the measurement. And the third one is to calculate the refractive index of a medium. Snell's law, most of you must be familiar with. All the input parameters are given, uncertainty is also given. So let this be a homework for all of you during the weekend. Okay? I shall send the slides to you. Should I send the answers also along with this one? But please genuinely give your try. Then you go look through the answers. Otherwise, in the YouTube also you will get the answers in the previous lectures. If anybody wants to leave by now, you can leave. If anybody wants to discuss whatever we have done till date, you can wait back. Others can leave. Give me the attendance sheet.